Good afternoon, everybody. So, can you just remember what we have learned in the last class? No one? You can see it is written there. So, we talked about basically the open channel flow and pipe flow, right? And also we have learned the classification of open channel flow, right? So, today I'm going to talk about what are the basic elements of open channel flow and what is the cross section of a channel, and also I will talk about basically the states of flow. Now we know by this time what are the types of open channel flow, but we have to know what are the states of a flow, right? So this is my today's topic. So let's see the definition of a channel section. So if I just take any cross section which is perfectly normal to the direction of flow. If flow occurs from left to right, and if I take a section from a direction which is normal to this flow, then we can call it a cross section. For example, it is here. So this is the channel bottom, and flow is occurring from left to right. So higher elevation from lower elevation. If I just take a section BD, which is perfectly normal to the direction of flow, so we'll have this type of shape. So this is called channel section. And if I take only the vertical section, which is the direction of G, gravitational force, we'll have this AA section. So this is called vertical channel section. And what about channel geometry? Channel geometry means the shape of the section. So we have just seen a section which is nearly parabolic, but if the section is regular, that means if it is rectangular section and if it just continues along the reach or length of the channel, then we can call it a prismatic channel. You see, so this is the section which is regular. When we design a canal or channel in real world situation, we design a channel like this way. So this is fixed along the length of a channel, right? So this is called prismatic channel. Otherwise, if the shape changes and if it is irregular, then we can call it non-prismatic channel, right? So what is the shape of non-prismatic channel? So it is like this. All the natural rivers or canals, that is not like this, right? So that's why it is irregular and we call it non-prismatic channel section. So this is the geometry of our channel section. So there are some other components of this channel section. So what are these components? So it has a depth of water. We call it depth of flow. See, if flow occurs from upper elevation to lower elevation, in this case from left to right, and if this is the bottom of the channel, and if I just take a distance from the water surface to the channel bottom directly vertical direction, right? So what I will get, it is the depth of flow, right? And there are another depth of flow section. So what is the depth of flow section? The same situation, and if I just take this distance from the channel bottom, which is perfectly normal to the direction of channel section. So see, if this is the channel bottom, and if I take this distance, which is D, denoted by D, so it is normal to this channel bottom. So this depth is called depth of flow section. So these are the elements. There are some other elements. See here, our channel section has a top width. If this is a section which is nearly parabolic section, it has a top width. So it is called top width. And then the water area. So if the channel holds a depth of water like D, so this shaded area is called water area. And what is the weighted perimeter? So if water is here, so it does what it is doing here. So see the red line or the purple line from here to here. At this portion, the water is just wetting the channel section. The length that is the intersection between channel and the water is called the wetted perimeter. Since it is a length, so it is called perimeter. There are some other component. It is called hydraulic radius. It is denoted by R. If I divide the cross-sectional area of the water area by the wetted perimeter, I will get the hydraulic radius, right? It is A divided by P. And there is another element which is called hydraulic depth. If I just divide the cross-sectional area with the top width of a cross-section, T, I will get hydraulic depth. We will use these two components in our calculation to understand what is the state of flow, right? So far we have understood the components of a channel section and what is the geometry of channel. So can you just tell me, if the hydraulic depth is A divided by P, where A is the cross-sectional area and T is the top width, so what will be the hydraulic depth of a rectangular section? See, so this is rectangular section, this is trapezoidal, and this is triangular. So for this rectangular section, so what will be the hydraulic depth? Can you answer this? Or can you just calculate this here? It is just a ratio of area divided by T. So the area of a rectangular section here is
B times Y.
Yeah, B into Y. And what will be the top width of this section? T. T is similar to B, the bottom width, right? So B and T is the same for rectangular section. So if I divide By divided by B, what I will get? I will get only the depth of water. That means for a rectangular channel, the situation is special. The depth of water is same as the hydraulic depth. And for other cases, it will be different, right? So now let's see. If the channel section changes from rectangular to trapezoidal, triangular, or it may be parabolic or circular, right? So we have a chart here already calculated these parameters. So when we need to calculate something, we can check the equation here and we can use the equation for calculating our hydraulic radius or hydraulic depth or cross-sectional area or any other parameter we can easily calculate. And now I'm going to talk about the state of flow. If I use this hydraulic radius and hydraulic depth, so I can easily calculate or I can understand what is the state of any type of flow. So based on the viscosity, the flow may be defined as laminar, transitional, or it may be turbulent flow. So we have a number called Reynolds number. So if the number is less than 500, then we can call it laminar flow, and if the number is more than 2000 for open channel flow, it is turbulent flow. So see, in laminar flow, the streamlines are perfectly parallel to each other, and for turbulent flow, the streamlines are not parallel, it is disturbed like this. So there is another number based on gravity, which is called Froude number. So based on this Froude number, we differentiate a flow from subcritical to critical, and it may be supercritical. If the number is less than 1, the flow is subcritical. If the number is 1, then the flow is critical, and if the number is greater than 1, the flow is supercritical, right? So this is the example of a flow where subcritical, critical, and supercritical flow occurs. When the flow is supercritical, the depth is very low, the velocity is very high. And when the flow is subcritical, most of the river flows in the real world situation is subcritical, and it is turbulent flow. See? So in summary, so a channel section may be triangular, rectangular, or it may be non-prismatic, right? So it has top width, bottom width, it has hydraulic depth, hydraulic radius, it has the depth of water, and the channel state may be linear or it may be turbulent based on the Reynolds number, right? And also the channel flow may be critical, subcritical, or supercritical based on the Froude number. If the Froude number is greater than 1, the flow is supercritical. If it is 1, it is critical, and if it is less than 1, it will be subcritical flow. So this is for today. So if you have any question.
Do you have any questions? No? All right, thank you.